All right, so I'm going to go ahead and draw like my axis coordinates on here just for the visual.
I'm excited.
All right, so I'm going to start out with degrees, doing them inside here.
Sorry, I heard something else. Are you okay? Don't eat that cookie.
All right, so we start at 0 degrees, and then we go around 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120.
Is this in a fancy color?
This is one of your colors.
Yes.
135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and all the way around is 360.
Is that 135 underneath 120?
Yes. Made them bigger.
Oh, that's a lot better, yeah.
What? Bro, what?
Why'd you say that?
Look.
You said the L word. That's one of them.
It's just the word, guys.
All right, radians now. I'm going to do these still inside the circle, but more on the outer edge of the circle. Pink. All right, so we start with 0. Now remember, we can count these around. I'm just going to label them all, and then we can go over counting if we need to, refresh on that. So we've got pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and then halfway around is pi.
Is that
Keep-
5 pi? Yeah.
5 pi over 6, yeah. We keep going, we get 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. And then when we get all the way around, it is 2 pi. So the thing that people most commonly miss when they're doing their radians and degrees are not putting both zeros and not putting both ending values of having gone all the way around one time. So just make sure that we're doing that.
You want another color? I have
Does
7
anyone need
colors.
pink or purple?
I would love a pink. I would love a pink. I would need a pink. I'll take a purple. Yes, sir. You need one of these?
There are more options over here as well if you
Are you blind?
Actually, I don't
need
need
something.
Can you move it up a little bit?
All right, I'm going to do a quick refresher on how we count these around because if you don't just memorize them straight up, then you can also count them off. So it splits into however many sections that produces for you within your, like, the top of your unit circle. So, say pi over 2's, okay? We start at 0, so if we split it in half, that's 1 pi over 2, 2 pi over 2, which reduces to pi. We'd keep going around 3 pi over 2, 4 pi over 2, which reduces to 2 pi. And I'm also reminding you of this because if I were to ask you what, like 6 pi over 2 is, you could keep counting around and get to it that way. Next thing I would look at are pi over 4, so that splits it into 4 sections, so that's going to be your increments of 45 degrees. And so we've got pi over 4, we've got 2 pi over 4, which reduced to 2 pi, 3 pi over 4, 4 pi over 4, and so on and so forth going around. And then when I'm looking at my pi over 3's and my pi over 6's, I can get all of the pi over 3's by just reducing pi over 6 values. Okay, so increments of 30 degrees. So 1 pi over 6, 2 pi over 6, but that reduces to pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6, and then 6 pi over 6 reduces to pi, and I could get it by continuing on around counting the same way. Now, I can just count my pi over 3's as my increments of 60 degrees. If I do that, though, I would just hit 1 pi over 3, 2 pi over 3, 3 pi over 3, and so on and so forth going around. Okay, questions about that? You kind of vaguely remember that from last year, hopefully. Okay. So next thing I'm going to do is I'm going to put my axis values, my XY coordinates on my x-axis and y-axis out here in one color. So if you're using, I think, 7 colors, this would be one. If you are not using all 7 colors, you can do whatever. But I'm going to do those in yellow because there's only 4 of them, and that way, whatever. All right, so out here, this would be the 0.10. So remember, the radius of our unit circle is 1, and so that's where these values are coming from. Up here would be 0, 1. Over here would be -1, 0. And then down here would be 0, -1. And it might be smart on your axis to go ahead and just make sure that you know that that's your x-axis, that's your y-axis. I mean, the paper, if you did it in the way where the word unit circle is up here, it probably is pretty obvious which way it goes, but just for reference for you, you might want to pay attention to that. All right, the next thing I'm going to do is I'm going to do the increments of pi over 4 putting their x and y values because they are all √2/2, both the x and the y value. The only thing that changes as I hit each increment of pi over 4, and these are the ones that specifically have a 4 on the bottom, is their sign based on where I am. Okay, because remember, quadrant 1 up here, I'm positive, positive. Quadrant 2, I'm negative, positive. Quadrant 3, I'm negative, negative. And then quadrant 4, I am positive, negative. Okay, so that's going to be the only thing that changes as we go. So this is going to be another color. So increments of pi over 4, we've got √2/2 and √2/2. At 3 pi over 4, I'm negative √2/2 and then positive √2/2. At 5 pi over 4, both are negative, so negative √2/2 and negative √2/2. Then 7 pi over 4, it's positive, negative, so √2/2 and then negative √2/2.
And which is the sine or cosine?
Do what?
Is the sine or cosine? Or wait, they're both.
Cosine is x, sine is y.
Okay.
All right, I'm going to do another color. I'm going to do pi over 6's now. And remember, you can kind of roughly estimate if you forget which one, say, especially on like the pi over 6 and the pi over 3, you can kind of roughly estimate. You don't need to draw this, but like if I drop down here from where this is almost all the way to 1. It's just a little bit shy of that. And so root 3 over 2 is about 0.86. And so that would be your x value there is going to be root 3 over 2. And then you can kind of estimate going across this way. That's about, or looks to be about halfway between. And so 1/2 is going to be the y value. So if you mix them up, just try to like draw a line down from where it would be and approximate what it is, because you only have a handful of numbers that you have to remember for these things. So this is root 3 over 2 and 1/2. And again, all the ones that have a 6 as the denominator are going to have the same thing. So I've got over here negative root 3 over 2 and positive 1/2. At 7 pi over 6, I've got both are negative, so negative root 3 over 2 and negative 1/2. And then at 11 pi over 6, I've got a positive root 3 over 2 and a negative 1/2. All right, then another color for our pi over 3s. So I've got, basically on these ones, it just swaps your pi over 6s. Okay, so just swap the x and y values. So pi over 3 is 1/2 and root 3 over 2. And then those numbers stay that way all the way around except for the signs change. So at 2 pi over 3, I have negative 1/2 and positive root 3 over 2. At 4 pi over 3, I have both are negative, so negative 1/2 and negative root 3 over 2. 5 pi over 3, positive 1/2, negative root 3 over 2. So remember, the cosine values, if I ask you, because this is going to be what part of our first section is in this, or like part of the next section, the first little bit of it is going to be finding the different pieces of the triangle, but then after that it's going to be like, all right, what's the cosine of 45? Okay, and so you would be looking at the x value to find that, which is root 2 over 2. Did you have a question, Shepard?
That's negative 1/2 at the top left, correct?
Yes.
Okay, let's go down to the bottom line.
All right, so the last thing that we need to put on here are our tangent values. So if you don't want to memorize your tangent values, or you're like, this is already too much to memorize, if you memorize your x and y values, you can easily find the tangent values by doing y over x. So remember, tangent is sine over cosine, y over x, and so I can do a lot of keep, change, flip for Shepard, and we can find those tangent values really easily. So I'm going to use another color for tangent.
Dan's like black.
Can I get the pink?
Here. That's my nice one. Don't mess it up.
All right, so tangent values, I'm just going to go, well, I'll do it kind of the same way. So I'll start with pi over 4s. All the tangent values are going to be one color, but, I mean, you can do whatever you want, but I'm going to just start with the pi over 4s. So root 2 over 2 divided by root 2 over 2 would be what? 1. So all of the tangents of and increments of pi over 4 are 1 or negative 1. So over here, both signs are positive, so that means it's a positive. At 3 pi over 4, one's positive, one's negative, so that means it's going to be negative 1.
This should be the same color as the one that we did this.
No, I'm doing all the tangents in one color.
Okay.
I mean, it's up to you, but that's what I'm doing. The tangent of 5 pi over 4, both are negative, so that means that the tangent's going to be positive 1. And then at 7 pi over 4, I've got a negative y and a positive x, so that's going to be negative 1.
Nice.
All right, so then I'm going to go through pi over 6s. So 1/2 divided by root 3 over 2 is going to end up being 1 over root 3. Rationalize it, we get root 3 over 3. So all of the pi over 6s are going to either be positive root 3 over 3 or negative root 3 over 3. So over here, I've got a negative root 3 over 3 because I've got one positive, one negative. At 7 pi over 6, both are negative, so that means that it's going to be positive root 3 over 3. And then at 11 pi over 6, one's negative, one's positive, so that's going to be negative root 3 over 3. All right, the pi over 3s, I've got root 3 over 2 divided by 1/2, which is root 3, because root 3 over 2 times 2 over 1 is root 3. So all of the increments of pi over 3 are root 3. The sign just changes. So at 2 pi over 3, that's going to be negative root 3. At 4 pi over 3, that's going to be a positive root 3. And then at 5 pi over 3, it's going to be a negative root 3.
Top left is negative.
Yep. So all the tangent values in quadrant 1 and quadrant 3 are positive because the signs are the same. In quadrants 2 and 4, they're all negative because they are opposite signs. Now, I have not put the tangent values on my x and my y axis. So on my x-axis, I have 0 divided by 1, which is
You can't do that.
0. So the tangent on the x-axis is 0. What about my tangent on my y-axis? 1 divided by 0. Undefined.
I still do right.
Now, for these first few things, essentially, I'm going to, you'll be filling out a unit circle as part of your, quiz for either, extra credit or something like that. But probably because there's a lot of you, kind of like what I had to do last year, is I won't be able to grade it, as you're going, so I'll give you a copy of mine afterwards while I grade them. The only thing is, unless I reprint them, with, say, this new one or whatever, the tangent values on the x and y axis are not on here. Okay, so you're going to have to know those. Now, what I'm also going to tell you is we're going to quiz on this next week. But you need to not just forget it when we get to the point where I'm just giving you one of these. I think it's chapter 5. I'll probably just start giving you one of these just for the sake of time, because that's, hopefully by that point you will have proven that you know this unit circle like the back of your hand. Okay, so on the AP exam, they don't give you a unit circle. Okay, so these values need to be ingrained in your brain. And I don't even, I wouldn't even say that you should, write them down when you necessarily get to the exam, because it probably, it'd be a waste of your time to write them down, in my opinion, unless you get to a question that you really need it. Just write out the parts that you need when you get to those respective questions, okay? So make sure that you know this stuff, not just to get through a quiz in a week, but to get through the rest of the year. Okay. Are there any questions about anything on the unit circle, how it works, anything like that? I mean, I know you've all done it before. I'm also not going to give all the free chances that I've given in the past. This is now AP Pre-Cal, and you should be able to get through it. We're going to have a 1 practice quiz and then a real quiz, and I'll take the higher of the 2 grades. So I will still do that, but I would really hope that on the retake you don't do worse than you did on the first one. There are 66 things, I think it is. I have to go back and count. I always forget. But I grade it out of 64, so you have a little bit of wiggle room as far as some extra points. But everything that I have labeled on here, you will need to label. What we're going to do, this is Wednesday. So on Tuesday, we'll do the practice quiz. And then either Thursday or Friday of next week, we'll do the real one. So that way I can grade it and give it back to you on Wednesday so that you'll know if you have to retake it or not. Whatever grade you get on the practice one will get put into GradeLink. If you do better on the retake, it will get replaced. Okay? If you get a 100 or better on the initial one, you do not have to retake it, but you're welcome to do it if you want to. If you don't get all the points, like if you're like, I missed 2 things, I want to see if I can get the extra credit points, you can retake it and try to get the extra credit points. So, questions about that? All right, that's all we're going to do for today. Tomorrow we're going to start into section 4.2. It's going to be the stuff where we're looking at a triangle and listing all the different values. Those of you that were in college algebra last year, we did a ridiculous amount of those, so hopefully it'll just be a little refresher for you. We obviously did them in Algebra 2 as well, but not nearly as many as the college algebra book makes you do. So we'll do that, and then we'll be using our unit circle. So make sure you have your unit circles like with you and handy for class and stuff like that, so that you can use them unless you've got it. Once you've got it memorized, not as big of a deal, but if you've forgotten it, make sure you have that knowledge there.